Okay, let's talk about polygons for a little bit. We know that a polygon is a figure. It's got to be closed, which means there's no openings. All the sides connect together. There's no curved surfaces, so circles is not included in this list because it all has to be straight sides using line segments. And these can be either what's called concave or convex. And so let's zoom in for a minute and look right here at these two examples. Convex, if you look at all the angles, they're all going out. Concave, we have that one that you can think of it that it's caving in to the middle. So convex means they're all pointing out, just like every regular shape, a triangle, a rectangle. All those that you're used to seeing are all convex. Concave are some that are not your typical shapes, but we have some that cave in, like a star is concave because we have those angles that are going in. And so here are some examples of polygons and some that are not polygons. And so we can see our convex and concave examples, and then we can see the two that are not. One, this one right here in green, is not because we have those curved surfaces. And this one right here in pink is not because it's not closed. So to be a polygon, it has to be closed, has to have straight sides, and it has to have at least 3 sides. So let's talk about these that we looked at in our warm-up today. And so our polygons, we name them by the number of sides they have. Okay. Hopefully you knew several of these. So let's just check and see what you knew and what you didn't know. Fill in the ones you didn't know. So obviously 3-sided is a triangle. 4-sided is a quadrilateral. Yes, it looks like a rectangle, but there are several types of 4-sided figures that we're going to break into in a little bit. And so all those 4-sided figures are called a quadrilateral. 5-sided figure is a pentagon. 6-sided is a hexagon. 7-sided is a heptagon. 8-sided is octagon. 9-sided is a nonagon. 10-sided is a decagon. I don't know why that rectangular box keeps popping up. Just ignore it. 11-sided is an undecagon. And 12-sided is a dodecagon. Past that, we really don't have shapes. We just say, like, if let's say it has 25 sides, we would call it a 25gon. It has 35 sides, 35gon. So N just stands for the number of sides. Okay, so now what we're going to talk about with these polygons is how to find the interior angles, the ones on the inside, and how to find the ones on the outside. So we've got a couple formulas that we're going to look at here. So go ahead and go to the next page. I'm going to give you the formulas and then I'm going to show you why those formulas are the way they are. So sum of an interior angle, to do that we would take 180 times n minus 2. N again stands for a number of sides. So let me explain why this formula exists. So I'm going to go back here for a second. We know that triangles have 180. We know that because we've spent a lot of time talking about triangles. So let's say I take this pentagon, the 5-sided figure, and I pick a vertex and I cut it into some triangles. So I connect all the non-adjacent vertices. So not this one here I just did because that's an adjacent side. So we want to do the non-adjacent ones. We see that it creates 3 triangles. Do you see that? 1, 2, and 3. Okay. So if each triangle is 180 degrees, 3 times 180 would give us the amount of degrees in that pentagon. Same thing with the hexagon if we look at it. If I pick a vertex, doesn't matter which one, and I connect all the non-adjacent vertices, I can see that I have 1, 2, 3, 4 triangles. Well, let's go back here for a second. Pentagon had 5 sides. It gave us 3 triangles. Hexagon had 6 sides. It gave us 4 triangles. If we do a heptagon, pick a vertex, connect all the non-adjacent sides, we can see 1, 2, 3, 4, 5 triangles. So we can see that the pattern is to get the number of triangles, we subtract 2 from each side length. So we know if we were doing a decagon, we now know without having to draw it or connect the triangles, there would be 8 triangles in that one. So that's why the formula is 180 times n minus 2. You have to take that number of sides minus 2 to get your number of triangles that would be formed. Then, so let's practice a few of those just to make sure you understand. Let's look at practice 1 and practice 2. First thing you need to always identify is your n. Well, if we're working here with an undecagon, we know that our n would be 11. So to find that, we would say 180 times 11 minus 2. So 9 times 180 would give us 1,620 degrees. Let's practice the next one. We have a 20gon. So we're going to take our formula, 180 times 20 minus 2, or you can go and do the subtraction in your head and just say 180 times 18 in your calculator. That is perfectly okay, as long as you remember to subtract 2. And you would get 3,240 degrees total if you were to add up all the angles in a 20gon. Doesn't matter how you draw it, it's always going to add up to 3,240 degrees. Okay, so there's the interior angles. Now let's talk about your exterior. And again, this is the sum, so that means all the angles together, not each little angle, all of them together. This one's a very, very easy formula. There really isn't a formula because it doesn't matter what shape you have, all your angles on the outside will always add up to 360. And when I say angles on the outside, let me give you a visual here. If we're looking here at this picture, I'm talking about this one, and this one together. Those are always going to add up to 360. It does not matter which figure we're talking about, the answer is always 360. So I don't even have to think about what my n is. If it says sum of exterior, my answer is always going to be 360. Sum of exterior, the answer is always 360. So that's how those two formulas work. A couple of things to pay attention to. One, is it interior or exterior? And two, is it asking for the sum? Because we will do something else here in a minute. And also, what is your n? How many sides does the figure have? Now, if we want to figure out what each angle is, so if we have our sum and we want to figure out what each angle is, the only way to do that is if you have what's called a regular polygon. And that just means that all the sides and all the angles are the same. So you might make a note of this vocabulary word right here. Things like equilateral triangles, squares, your typical pentagon and hexagon that you're used to seeing. But when you see a shape like that, and I'm just going to do a square because that's easy and quick for me to draw, you have to be told that it's either regular or that you see those tick marks on the outside of your shape. Okay, you have to see that for this to work. Now if we look here, we're taking our question and we're adding the word each in front of it. Each interior and each exterior. So if I know my sum, let's say we know the sum of that undecagon up there is 1,620, and I want to know what each of those 11 angles equals, obviously all I have to do is divide that by the 11. So there's our formula that we're going to be working with here. So we're going to take the formula we started with, 180 times n minus 2, and we're going to divide it by the number of sides. Okay? Each exterior, if we know they're always going to add up to 360, then we can take that 360, divide it by how many angles we have, and that'll give us the measure of each interior or each exterior polygon. Okay. Or angle, I'm sorry. So now let's look at practice 3. I'm going to pay attention to a couple of things. This one's asking for interior. This one's asking for exterior. They use the word each, not some, so we know we're going to have to divide at the end. And what is our n? Well, we're working with a dodecagon, so our n is going to be 12. Okay, so let's plug this in. We're going to say 180 times 12 minus 2, or you could go ahead and put a 10 there, divided by 12. And so all you do is plug that into your calculator, 180 times 10 divided by 12, and that would give you 150 degrees. Same thing here for each exterior. We know the sum is 360. We can divide it evenly by those 12 angles, and we're going to get 30 degrees. Now, let's look at something here. These two numbers together will always add up to 180. Always, because, and let's go back to this picture over here, your interior and exterior angle are a linear pair. So if you know one, you could always find the other if you forgot the formula. You always have the formulas to rely on, but you also know that those two angles, your interior and exterior angle, just the angle, not the sum, will always add up to 180. All right, last example here. We have to figure out what angle X is. Well, first of all, let's figure out what kind of shape we're working with. Let's count our sides. So we have 1, 2, 3, 4, 5, 6. We know we have a hexagon. Doesn't say it's regular. We know it's not regular because all the angles are different. But we want to find what that one is. Well, let's figure out what all the angles are supposed to add up in a hexagon first. So if we want to know our sum of the interior angles, we can go up here to our formula, 180 times n minus 2. We know our n is 6. So let's say 180 times 6 minus 2. And that gives us 720. So we know that all of those angles are supposed to add up to 720 degrees. That's step one. Step two, let's see how much we have here. So let's add all those angles up. So when I say add them up, I mean let's take 130, 130. There's 3 of them, so let's put those there. There's a 120, and there's a 90. If we add all those up, it does give us 600. And then if we can take that 600 away from the 720, we know we're left with 120 degrees for our X. So figure out how much it's all supposed to add up to, and then subtract what you have. And that's how you find your interior and exterior angles. So just pay attention to what the question is asking, and is it interior or exterior? Sum each, interior, exterior, and also figure out your number of sides.